I used to do drawings of rhinos and sell them to the other kids at school. And look back then, I was actually like doing some sort of business stuff as a little kid. But hey, we can prototype it, but it's going to cost you $100,000. That was what we were telling clients. And then under WNT's guidance, it was like, actually, this could be a product. And this could be huge.
And what was the reaction of the customers when you kind of pitch, or even now, like when you tell them we can do this much cheaper, much faster?
Biden brings out tariffs. They increase under Trump. It's both sides of the spectrum are going, we are absolutely stuffed if we can't manufacture. Because of my background in designing for manufacturing, I had enough knowledge to be dangerous. We're seeing our big markets as America, Europe, Japan. Right, three big markets for us. Kiwis are really smart. What we're finding is Kiwis are also very flexible in going, hey, I'll have a go at that.
This is Mark Pawlikowski, and welcome to the TechMates podcast, where my partner Henrik and I explore how Kiwi and Aussie founders are reshaping the future and what sets them apart. Henrik and I have been part of successful companies in Silicon Valley and Europe, and now bring that expertise to partner with entrepreneurs in Australasia. By sharing the personal stories of successful Kiwi and Aussie founders and how they got here, we hope to inspire you to dream big. This is TechMates, bringing an outsider's perspective to the stories of those daring to disrupt down under. Let's dive in.
David, welcome to TechMates. Thanks for joining us.
My pleasure. Thanks for having me on.
Awesome. So, you're founder of a Wellington-based company called Foundry Labs. You also grew up in New Zealand. We'd love to learn more about your background, how you grew up, and what it's like growing up in New Zealand. So maybe we start there.
Perfect. Well, there's a secret. I have a stealth childhood because I actually was born in South Africa and I left there when I was 12 to come here. So.
Oh, interesting. So can you maybe start there? Like how did your parents end up? Where are your parents originally from? How they
Gotcha. So my mum's from Kenya, but is a British expat. Dad is South African. Heritage is Scottish and English. So obviously, born in South Africa, born in Cape Town, down the very south. We had direct family who'd moved to New Zealand 20 years before we did. Mm-hmm. Yeah. So when my parents were looking at immigrating, it was kind of like a natural choice. We had family here already.
And what do you remember any memories from your childhood in South Africa?
Yeah, and quite a lot. I think I was 12, so I still remember a fair amount. It's an interesting place. I think as a 12-year-old, you're probably not as aware of culturally what's happening. Mm-hmm. I do remember now with fond memories, but at the time I was grumpy. I was at a friend's house playing computer games. Prince of Persia, if I remember correctly, the original. And his mum made us come off and watch Mandela's inauguration.
Wow.
And I remember being like, why am I watching? This is so boring. But yeah, huge things happening that obviously as a kid you're not there aware of.
Wow.
Yeah, so we immigrated obviously post-apartheid. So I got to see a bit of the changes in Africa, which was really interesting. And having gone back, it's amazing. Some of the stuff that's happened, obviously, it's also got its problems, but I don't think you have years and years of government-sanctioned racism without some issues.
Yeah.
An interesting place, very interesting place, very beautiful place.
Do you remember what it was like moving countries when you were 12? How did you feel when you got to New Zealand?
That was honestly didn't really, I think, register that we'd moved properly until about a year into it. It kind of felt like it was an adventure. Going to the supermarket was fun. It was like, what breakfast cereals do they have in this country?
And why is that? Did you not have a lot of options and stuff in South Africa? Or?
That's just very different, right? It's just a different world, different. Everything's kind of exciting. And, when you're new to a place, you do a bit of traveling and you're seeing new places. So yeah, I think it took about a year to really hit that I wasn't going to see my friends anymore, that this was just permanent. I've only been there once, so it was very permanent. And got lots of family, of course, still in South Africa. So that was huge. I think if we're talking entrepreneurial, I think that's had a really interesting effect in that I don't have those deep roots that I think a lot of people who've grown up in a neighborhood have. I've had to completely start from scratch. So I think there's a fair amount of resilience that grows with that.
Mm-hmm.
And I think as well, seeing my parents take such super brave moves, it was huge. And Dad had a really good position. He's an architect, really good position in South Africa, was a partner of a huge firm, and came to New Zealand and really never got to that sort of position again. So they took huge sacrifices for what they believed was going to be a better future for their kids. So from that perspective, I think as I say, probably pushed a whole lot of resilience into us. I've got two brothers, so three boys. We've all, I think, benefited hugely from that. I think if I'm honest, it was definitely the best move. Africa's beautiful, but New Zealand's my home, right? I've been here 2/3 of my life. New Zealand was very accepting of us. We were some of the first South Africans in our area, so before we've become too common.
Wow. And why did you guys, I mean, what was the kind of the impetus to move?
Education was the key factor, right? So education and safety. I think if you talk to South Africans, expats, they will tell you all these stories about how dangerous it is. A lot of it is actually true. But for my parents, it was a key thing there was education, which at the time was not looking good in South Africa. So the agreement they had with us was we were going to come here, we were going to do our schooling and university, and then we were free to go back. And none of us have come back. New Zealanders are fantastic. It's it's a really beautiful environment. We're all quite outdoorsy, into the surfing, into the hunting, and all the rest. So it really suits us very well.
Yeah,
That's awesome.
I think that if you look at founders overall, I think globally, but also maybe in our portfolio, there tends to be a lot of immigrant founders, first generation or second generation. Do you think there's something to it that, that life experience makes you want to become an entrepreneur?
I think so. I think the same thing happens, and maybe I might be jumping too far ahead here, but I think, you go to university, you do a degree, you kind of feel like you have to do that. You have to stay in that degree. You have to stay, you don't want to lose your chance of kind of climbing up the ladder. I think it's similar to when you are an immigrant. You don't have those roots. You don't have those connections with certain people. You have to build it all from scratch. And I think it probably makes you a little bit less concerned about, protecting, the path that you think you have. You've got the opportunity. You can survive. So you've got opportunities and you can go for them.
Yeah, interesting. So it's sort of like there's nothing to lose, basically, right?
Yeah. I think there's this. I don't know when you do a degree or when you are comfortable in an area, there's a concern that if you don't stick in it, you're going to lose out. Mm-hmm. And I think when you realize that you don't die by dropping what it's kind of crazy, but you think, hey, if I lose my job or if I leave my job, I'm going to starve to death. And I remember when I first went out entrepreneurial, I called my parents and I was like, I'm just going to do this, but I'm really concerned. And they said, how many people do you know that have starved to death? And I said, well, none. And they were like, which I think is great advice. Like in the end, it's like, you're not going to, it can't go that wrong. Someone's going to look after you.
That's interesting. Why do you think? Yeah, because it would seem, right, logically, it's like the downside is fairly limited. I mean, sure, you maybe lose a year or two and nothing actually works out. The upside is pretty uncapped, but still there's a fear to doing something. Why do you think that? Where do you think it comes from?
I think that's that free fall, right? You suddenly, all your structure is gone, all your pathway to success or your pathway to comfort. Maybe that's what it is. It's comfort. I think if you've always lived within a certain comfort zone, then you don't want to lose that. I mean, there's nothing worse in this world than being uncomfortable, right? One problems. But I think maybe that's what it is. It's just like, hey, I know I can survive discomfort. I can live with it. And to be fair, that's the founder journey from start to finish, isn't it?
Yeah.
You just, or Elon calls it eating glass. It is uncomfortable all the time.
Yeah.
And I think once you get used to the fact that you can live with that, you can live with the dichotomy of it's going to be all right, but it's not all right now.
Yeah.
Maybe that's something to do with it.
Were you always like that? You moved to New Zealand and it starts being uncomfortable. I guess, maybe was it uncomfortable? And then did you always then chase new things and chase discomfort? Kind of how did that evolve in you after you?
No, I think, okay. So looking back, maybe I was entrepreneurial. It didn't seem like a really big path in my life. I guess naturally, maybe a little bit introvert, extrovert, just looking back at primary school, I did things now that I look at selling. I used to save the rhinos, right? I used to do drawings of rhinos and sell them to the other kids at school. And I look back then and go, oh, shoot, I was actually doing some sort of business stuff as a little kid, but it wasn't, I didn't really think about doing business and things. I think my upbringing was a lot of you stay true to your boss and you work and kind of my father has been incredible at how he's been, what's the correct word to use? He's stuck at a job and he's worked through and he's been for that company, for long periods of time. And that's kind of that's the sort of role model I had, was that actually you stick it out and you work at it. And it wasn't until I actually think I hit discomfort in my jobs that I was doing that I started looking at my alternatives and going, okay, well, I could go out. So essentially maybe we'll jump ahead in time. I was working, I did degree in industrial design. And I worked for 15 years in consultancy work. And towards the end of that, started thinking, hey, I think I can, there might be a better way to do this. And somewhat naively as well, when you actually start a business, you realize actually there's a lot going on more than you knew as an employee. But I think
maybe to go back, why did you study industrial design? What was your interest?
Yeah. Okay. All right. Always been artistic, I guess. Always very creative. Thought I wanted to be a pilot. Got quite far down that track with getting my prospectuses and things. I loved aircraft. My parents then sat me down in the final year of high school, and just said, "Hey, is that the life you want to live?" And I think, having a hard stare at what being a pilot actually meant in terms of family life and in terms of that, going, actually, no, that's probably not what I want.
So it sounds like you're kind of recreating that with all the traveling you do.
I've got enough hours on the aircraft now that I could be a commercial pilot. I think then I thought I'd do architecture like my father. And he sat down with me and said, hey, if I could do it again, I would do industrial design. And I'd never even heard of it. So he and I looked at it and I was like, wow, that's exactly me. That's bang on with the kind of things I like to do. Played a lot of Lego, spent a lot of time building things in wood. We had Meccano as kids. So very much liked to build and be creative. But not so much, I didn't want to be a mechanic. I like the design side of things. I like the creating nothing out of nothing. Yeah. Went into industrial design. After that, the first year was kind of very broad. So it was with the architecture people, with the industrial, with the interior design. So you kind of got a good look at everything. But industrial definitely was what I liked. And I think it, because it allowed me that entrepreneurial, that sort of creativity to, and especially consultancy, which is what I was drawn to, was new client every couple of months, a whole bunch of R&D work, figuring out, can we make a product for this customer that's going to beat the other customers? So there's a whole lot of these parallels with starting up a startup, right? And going, and then going into the design work and figuring out how you can make this thing cheaper, and then working with manufacturers and stuff. So very much I've kind of stayed in the same line of thinking, but ended up with my own product.
And so you had like a 15-year career in different consulting roles. When did you start thinking about, oh, maybe there's a better way to do this?
Yeah, 10 years in. So I did 5 years in my own consultancy, or thereabouts. I think I got to the point working for other people where and again, as I say, probably naively thought there was better ways of doing things, and really kind of wanted to have a go at it myself. So I started up my own consultancy, which was a huge, for me, it was a huge step, right? Jumping out of the comfort of I've got a job that pays to starting a consultancy. It was interesting times, right? If you are doing consultancy work, it's feast and famine. You are either there's a lot of work and you're trying to find people to help you, nothing left, and you're paying people out of your pocket. I ended up with one staff member, and then we had contractors that would bring in, and it was feeding us both. But it was maybe this is going to be the theme of this whole talk, is discomfort. I think it was definitely prepping me for this discomfort idea, where you're looking, again, an Elon quote, but you're looking into the abyss, right? When there's just no work coming in, and you're like, well, how am I going to survive this? You are forced to then go out and bang on doors, and you're forced to figure out ideas. And in the time, I actually started 3 different companies. So I had my tried a website company. It got one job, and then I decided that actually that wasn't for me. I started a container building, a container buildings company. Never got any work. And I had this consultancy. So I'd kind of started trying a whole bunch of different things. But again, in free fall, nothing to hold you back anymore. So why not try? And in the end, it's like, well, okay, I just had, I think, our first kid when I did the first one. Everyone's tired and gone to bed. Well, I've got an evening. I might as well start working on something. So
then you had your first kid.
Yeah, I think I had the first kid, or maybe we had 2 kids by the point I started out my design firm. But
wow,
yeah, scary.
That's crazy. Now, how did you? I mean, tell me a little bit of that. Like, what was your personal thought process around, like, is this a good idea? And then also, like, your wife or your partner, like, did she think, man, this is like, you're making good money, now you're going to like...
Yeah, okay. There was definitely a high level of frustration with where I was at. And so I was looking at these other options. Yeah, I think you wouldn't do it if you weren't naive enough. Even entrepreneurship, if you weren't naive enough, you wouldn't go down the track, right? I got quite far in my thinking, and then I started to chicken out. Actually, no, I don't, I can't do this. I've got kids. I've got a mortgage. And then you can take this one or leave this one on the podcast. But I was at a church and I had a woman come up to me and say, "Hey, I've got something from God for you." And I was like, "Okay." And she basically said, "I think you've climbed up a ladder. You're sitting on a diving board and you're about to back away from it." And she says, "God says jump," which was the most intense thing. Going like, well, that can only mean one thing right now because it was the biggest thing in my life. So it was like, okay, all right, I'll jump.
Wow.
And when I told my wife what had happened, she was on board. She was like, okay, that's.
So you're kind of looking for an external sign that tells you, just go.
I was looking to back out. I was starting to think that this is way too much risk with kids. Yeah, it kind of for me wasn't the external confirmation.
Wow. All right. Well, let's fast forward. So you're trying all these things, and then I know there's a microwave involved somewhere in the backyard. How do we get from here to?
Okay. So I'm running a design consultancy. I'm getting a lot of customers because we're a small consultancy. I think you're ending up with the fairly scrappy customers. You're not getting the big Fisher and Paykel's. You're getting the individuals and you tend towards that work because you need to get any work you can, right, as you're building your name. So I'm getting a lot of customers who are saying, "Hey, can you design me this thing?" Which we would design. And then they'll come back and say, "Right, can I have 10 of these so we can go and try them?" And that's fine in plastic. Most of what you end up doing in industrial design is mass-produced plastic. What was starting to happen was I was getting clients saying, "Hey, can you design me this thing?" And it's got a die casting. It's got a metal casting in it. And the customer never asks for casting unless they need a physical profile. So strength, or it's a thermal dissipation. You don't go metal unless you have to because it's expensive. Mostly the tooling is very expensive to do. So I was getting more and more of these customers and they'd say, "Can you make me this 10 of?" And I'd say, "Look, the plastic parts, yes, I can 3D print that. And I can get that done at a price. The metal, I can't. I can CNC machine you a piece of metal, but that's not going to give you the answers you need. Because casting is typically critical. So you need this thing in your testing, you need it to function as it would in production. So if you give them a slightly different part for certification, let's say, well, the easiest one is crash testing, right? If you crash test a component into a wall and it's made differently from the production one, it's going to behave differently. It's going to give you a different result. So this started to happen to us where people were getting their products rejected at certification because they weren't actually made the right way.
CNC is an extrusion-based method, right?
So that's you've got a block of metal and you've got a bit that you're coming in and you're cutting away the shape. So it's a subtractive process. So you've got chunk of metal and you're turning it, you're machining it away into the part that you need. 3D printing is even worse in terms of direct 3D printing a metal part. The physical properties are very hard to ascertain. They can change from batch to batch. So it is from a designer's point of view or an engineering point of view, it's a nightmare to work with. It's getting better, but I became convinced very quickly that wasn't going to solve the problem that we were having.
Then what is die casting? What do they actually need?
Okay, so die casting is you take a block of metal and you cut out the shape that you want, so the negative of the shape that you want, and then you're injecting metal into that. Molten metal gets injected. So casting, if you boil it down to the simplest form, you've got a mold with the shape that you want, and you've got a crucible full of metal that you melt, and you're pouring that molten metal into the mold. Now, we've been doing that for about 8,000 years. The first casting, which is a frog that first casting we know about, is about 8,000 years, I think somewhere around there.
Wow.
And we're doing it the same way. So I went to the Met in New York fairly recently, and they had a display on Egyptian manufacturers.
Wow.
It was casting there, and it was identical to what we do now, which is quite telling. And I'll talk about that later on. But we've been doing the same thing forever. 150 years ago, we figured out die casting. Was, hey, we can pressurize that metal and get better castings. But essentially, it's still the same thing. You've got metal that's been poured into a cavity. Okay, so I'm stepping all the way back. So we're getting asked to make these parts. We're having to say no to customers. I'm starting to send customers to production with parts that we haven't been able to test. And sometimes we're talking up to $100,000 for tooling. So the mold to actually get the middle part might cost you $80,000, $100,000. And I've got my neck on the line for it. Hey, I've designed it to the best of my knowledge. You're going to have to go and spend this money, and we're going to find out whether it works. So that was getting scary. I guess I realized that problem wasn't going to go away. And I was maybe not making a name for myself, but I was starting to take on those kinds of projects that were maybe scary.
Because you had to.
I had to. Yeah. This is survival, right?
And scary as in like could they sue you if something goes wrong, or is your reputation?
It depends on your contract, right? And so it's mostly reputation. It depends on your contract, but I would definitely keep towards the side of, hey, look, I'm not guaranteeing anything. We're doing this to the best of our knowledge. Yeah. And so the thing would be, hey, we can prototype it, but it's going to cost you $100,000. That was what we were telling clients. So in absolute frustration, I thought, well, there has to be a solution to this. There has to be some way to get to a casting without tooling, because essentially that's the problem. The tooling cost is so high. So I started trying all sorts of things in my spare time, in the backyard, a lot of stuff, and I started 3D printing molds. I was working with a guy, Jim Collins. We started printing molds with gypsum, so plaster of Paris, and they didn't work great, but they gave us the first inkling that this was going to work. And so I was tinkering, making parts, doing casting in the backyard. So this is, face shield on, leather aprons. I don't know if you know much about casting, but if you're pouring, which country are we in? New Zealand. Aluminum. If it hits moisture, it explodes. So it is actually fairly scary.
Oh, wow.
Doing all this sort of stuff, having complaints from the people in my workspace because I was smelling everything out with the, burning stuff. And then what happened was I had a phone call from a VC, and this was Laura Falconer from WNT Ventures. She called up, said, "Hey, look, I'm fresh from America to New Zealand. I'm looking for deal flow." Who knows what deal flow is? Yeah, carry on the conversation. And she said that she was going around all the industrial design consultancies because they were typically working on leading edge stuff, cutting edge stuff. And can she come and have a look at my client work? So obviously spoke to all my clients. Everyone thought there was a potential to get some money. So, absolutely. So she came down to look at what we were doing. And at the end of about an hour, looking at our client work, just said, look, none of this is investable. And then she kind of looked at her watch and went, look, I've got an hour before my flight. What else can you show me? And I was like, well, look, I'm tinkering in the backyard. I think at that stage, I wasn't in the bathtub yet, but I was in the backyard with this stuff.
Did you say you weren't in the bathtub yet?
Yeah, that comes later. So I said to her, like, you can't invest in this because this is not even proven yet. This is just a crazy idea that I'm working on, but here's the problem I'm trying to solve. And she went, that's something we can invest in. And she left, got on Google and Googled what is a VC. Why does she want to give me money? Like, what is the play here? And so it was a fantastic learning curve. They were lovely working with me and kind of getting me up to speed. So that was fantastic. They eventually invested. And the idea was I would shut down my consultancy and work on this, but I had 3 kids in a mortgage, so there was no way that was happening. So they very kindly gave me a year to get to the point where either one or the other, is this going to fly or not?
Wait, so they invested while you still had the consultancy?
I still had the consultancy and I was doing both. And I can highly recommend to any entrepreneurs out there, don't do that. Back yourself and go with one or the other. It was insane. It was working all day on client stuff, and client work. You'd have a deadline that you just had to hit. So you'd be working crazy hours, and then when that was finished, you would late at night get onto this Foundry Lab stuff. Oh. So it was nuts. It was unhealthy.
How long did you do this? Just like double work,
and fully driven by fear. Right? I can't run out of money.
What was that period that you had to do both?
About a year. It was about a year that I was doing both. It allowed us to get to this point where I figured out that everyone I showed to what I was doing, they would say, David, this is fantastic, but you're a madman because there's aluminum flying around the room and this, fumes everywhere, and I'm wearing this full outfit whilst I'm pouring metal. And everyone going, look, I really like the tech, but I would never do that, David. Like that's a foundry. And so I kind of got to this point where you're going, okay, actually, is half the problem here that people don't want to work in a foundry.
So sorry, and David, you were making these casts out of what? Out of the gypsum, you said?
Out of gypsum, yeah. So I tried a bunch of different things, right? I was trying epoxy molds, and I was trying gypsum molds, and I was trying.
And you're saying these epoxy and gypsum molds, they would actually hold molten aluminum or molten metal?
Yeah.
Wow.
We were borderline, but I was getting parts out of it. Probably poisoning myself in the process.
Shit.
It was working-ish enough to make me know that there was a there, right?
Basically, the validation you were getting was that now that I've poured your mold, or now that I've made your part by pouring it into a mold, you can now do the test you want to do, right? Which you can do with CNC or 3D printing. Is that sort of the...
Yeah, correct. So the thinking there was that I could get the physical properties of a casting without the tooling. So it was super important to me that we were casting, and I wasn't trying to make up a new kind of casting. I was just trying to get rid of the tooling at the time.
And just remind me one more time. So what would folks typically do to get the molds without having to like make them out of gypsum? Like would they CNC the molds themselves?
Yeah. So you didn't have a choice. So your choice was spend the $80,000 or $100,000 to get the part, or you CNC the part. And so the CNC the parts, and we've now, maybe I can't mention that, on working with an automotive company who are saying that prior to what we did, they were getting 60% of the knowledge they needed. So you CNC machine a part, it gives you some data, but not enough.
No, but even the mold itself. So it sounds like the problem was in the mold, right? So what would be the process? Like this 100K you're saying people would spend, what would be the process to make the mold traditionally?
Correct, machine. So you'd CNC machine the mold, yeah. And that's where your cost comes in.
I see. Cool. Okay.
And so, there are people that are doing other things. So there's you can make a wax part and dip it in ceramic and slowly dry it. It's called investment casting, which is what the Egyptians were doing. So there are these other ways, but they tend to be very expensive. And you kind of have all these different castings will give you different results. So there's three main, there's sand casting, investment casting, or die casting are your three key casting methods. And each one gives you a different kind of part. And my problem was, we were doing parts that would be quite, thin wall, which means you can't use sand casting. It's not an option. And you're also looking for certain strength profiles that you couldn't get out of. So when you're a designer, you gravitate towards the right method for the product that you're doing. So if I need a high strength or a high elongation or whatever you'll be heading towards, or I need the lowest per part cost would determine which method you'd go for. But all of those methods have a long lead time. So we're talking 6 months plus, and then they are all high cost because no matter what you do, you end up having to build a positive to create a negative, or you'd have to build a mold. So all of them have a cost and a lead time associated.
Got it.
How much were you able to cut the costs from this originally 80 to 100K? And how much were you able to cut the lead time, the 6 months that you were saying?
Yeah. Well, now, or you mean back then?
Back then and now, maybe?
So I would have cut the $10,000 cost down to a couple of hundred, 300 or 400. But there is, caveat here. You make a $100,000 mold, that's going to last a long time. You could make maybe 50,000 or 100,000 parts out of that mold. My molds were lasting between 1 and 5. So there's a niche that this fits.
Right.
Short run doing your testing, and I was only looking at prototyping. I wasn't looking at production. And that was fine. If I could get one part out at $400, that's significantly cheaper for the customer in the short run. Yeah.
And so you're working on this for a year, and what kind of gave you or what was the milestone you achieved to say, okay, enough with the consulting work, I'm going to go full time into this?
Yeah. So, well, actually, I'll step back a little bit in that. So I had been told by everyone that I was mad, that this is Foundry, and kind of looking at that, and from an industrial designer's perspective, you're always user first, right? You're always trying to figure out how's a customer going to use this stuff. So I approached it from that angle and went, well, if I'm expecting people to buy a machine off me that casts for them, is it fair to make them put on a face shield and become a Foundry? Do they need to have, extraction? So I was looking into it. I bought an induction machine. I don't know if you know what that means, but it's essentially, a copper coil, and you can melt metal inside the coil. It's switching poles constantly, and it just vibrates and heats up the metal. There were all these different ways of melting metal, and all of them had these drawbacks. And then I was heating up my lunch in the microwave. And one of the key things with all these other methods is very, depending on where you place your charge, your metal inside like an induction coil, is how efficient it's going to be, whether it's going to melt at all or whether it's going to take ages. And I was watching the microwave and going, that's cooking my meal, regardless of where I put it in the microwave. Somehow anything inside that microwave box is within the field. And so it's like, well, that's ideally what I need. I don't want the user to have to line things up. And, I just want them I want this to be easy. Mm-hmm. the thought then was, well, and actually I can show you a mold, right? So you've got a mold. I was going, well, instead of pouring the metal from melting the metal and then pouring it in, which is the dangerous point, why don't I just put all the metal inside the mold at the start and put that inside a microwave and let it go for it, right? And there are a multitude of reasons why you don't do that.
I've heard you're not supposed to put metal in the microwave,
including that, yeah. And I think this is naivety that lets you get there, right? Going, well, what have I got to lose? I can get a microwave from the equivalent of Walmart for $100. We cut some holes in it, didn't know that was dangerous, and I started melting metal in it and going, oh shoot, that was easy. In fact, I even melted stainless steel in the early days, which is high temperature. It's like
why do people tell you not to put metal in the microwave?
You can't. You shouldn't. It creates plasma. Microwaves are a really interesting beast, and we've had to learn a lot about it. But essentially, you put metal in a microwave, and if you've got points, like let's say a fork, which is the classic one that people, or tin foil, if you've got points, microwave runs along the skin of a part. So on that one, it's fine. It's running along the skin. But if you had 2 points, it might be easier for it to arc between the 2 points than it is for it to run along the skin. So, and then what you do is you create plasma, which is what all the holy grail for all the fusion startups. We do it all the time. In fact, we spend most of our time trying to stop it from happening. But plasma essentially is a superheated gas that it can just melt its way through things. So it's like a very hot ghost that's so you really don't want it unless you can control it.
So basically, as the microwave is traveling along the edge and it jumps, while it's jumping, it makes the air into into plasma.
Correct. Yeah.
Which is then itself very, very hot, and you're saying can melt through stuff.
Yeah. So if you can, and then what's interesting there is that your microwave keeps feeding it, which is how fusion works. So you've got a plasma ball, and now microwave is getting attracted to the plasma, and that's growing and growing. So you can sustain the plasma, and that's when, apart from ruining your cast, it's a bit dangerous.
Like, can you just indulge me for a minute? So like, what happens if I just put a piece of metal in the microwave and I just let it go? Like, what is like?
It's luckily enough, most of the time, it's just going to kill your microwave.
Okay.
Yeah. If you manage to sustain a plasma, which is not actually that easy to do, but then it's got the potential, I guess, to melt its way through the side of the microwave. And
then just keep going, or it would stop at that point?
No, my guess would be that because you're no longer feeding it. Any microwave experts that watch this are going to be sitting there going, oh my goodness.
Don't try this at home.
This is microwave from non-experts. I guess you're no longer powering it, so it would probably just dissipate.
I see. Okay, so you you're like, all right, I'm gonna eat my lunch, and you realize there's this basically even distribution of heat that was happening that you wanted to basically replicate.
I wanted the ability to be able to put a mold anywhere inside the microwave and to get it wrong and still be right. And that comes from the industrial designer's perspective of, am I expecting people to be really awesome at this, therefore need a ton of training, or can I make this so simple? Like, I don't know anyone who can't heat up their lunch in the microwave, right? So the thought was, if they can get it inside the box and push the button, then they're done.
So the problem you were actually trying to solve wasn't like, can we make die cast molds? It was like, how do I let you do it on premise without having to like suit up and become a foundry?
Correct. So I was now trying to do two things at once. But it was combined, going, okay, can I get it outside of having to have a mold? Yes, but how do I do that if I don't want to be a foundry? Now, kind of proven with the gypsum stuff that it was plausible.
I see.
Yeah.
So you sort of proved that like it was possible to do with this sort of new, sort of novel material. But then you were like, but actually the process of getting it into the material, that's the thing that I can't replicate. Like, I can't just give it to somebody to do. So then, okay, so you sort of switch problems, right? That's pretty interesting that you like.
Correct. Yeah. So I'd actually taken my molds to a foundry and said, hey, can you cast into these? And they had a terrible time of it. So it was looking at that. And then it was also looking at, well, what am I ultimately trying to get out of here? And so I had been talking with WNT, the investor who come in early. And I'd said, look, what I'm going to do is I'm going to figure this out. And I'm going to sit in a garage and just have the world's cheapest, short run casting. And after a lot of talking about numbers with them, they persuaded me that actually selling machines was a far bigger bet to play, much more VC and less PE. And so that was kind of the thought. So I was like, okay, if I'm going to pivot towards giving people the opportunity to make their own castings, how do I, So it got infinitely more complicated because I was now trying to do two different things.
Right. So you actually were like, okay, this is good enough. I'm going to just like do basically my consulting thing, but just like I can offer more service, right? And they were like, don't do that. Let everyone be able to like cast.
Yeah. Yeah. I was initially, when I first started this, I was trying to fix a problem for my clients. That was I hadn't thought much beyond that. I was just like, this is stupid that I'm having to spend $100K on a tool without knowing. So can I fix that for my client? Can I get my neck off the line by going, hey, look, we've tested it. It works. Cool. Let's carry on with the design. So it was never supposed to be a product initially. And then under WNT's guidance, it was like, actually, this could be a product and this could be huge. So, okay. So now we've shifted towards that. Microwave seems like a good idea. With the money that I was given, I hired a guy. He helped me build the first printer, or he took charge and built the first printer so that we could start doing this stuff ourselves and start messing with materials. The problem of buying a printer off the shelf, and we're talking ceramic powders, gypsum powders and things, you can't just play with them. Or at that time, you couldn't keep changing what was in there. So we kind of had to build a platform ourselves. We found this Dutch guy who had made an open source, very simple project. So I flew across to Holland and met with the guy, got an idea that this was possible, and we kind of started with his open source project. Very quickly got ahead of him, which was great. And so again, hiring people who were just super flexible. And so this is Josh, one of my first hires.
The Dutch guy was Josh.
Sorry, the New Zealand guy that I'd hired.
Oh, okay.
I figured out a whole bunch about printing. In isolation, one of the problems with New Zealand, right, it's beautiful, it's also isolated. And so access to the people who've done stuff before is often a problem. So what we call in Foundry Lab anyway, brute forcing. We do it, we just don't have an option. So you have to figure stuff out. And we can talk about that a little bit later, but that has its pros and cons. So we built this machine. We were using a microwave off the shelf and the warehouse. I think we might, put quite a lot of money through the warehouse because we would blow these things up and then have to go and buy more. We actually had a cupboard full of them. We had a graveyard, but we got to the point where it was kind of working, and then started to run out of money as startups do, and so then it was going out and trying to find investors.
That's what David. But like it was just it would just work. Like you would just take that mold you were showing us, you'd slot in the metal, up it into like a regular microwave that I have in my kitchen, set the timer, walk away, and it would actually produce the part for you.
Yeah. Okay. So this is the gain to the naivety. Yeah. The parts looked reasonable. Not until you get a metallurgist on board do you realize how bad the castings were. But again, I think this is part of the thing about being in isolation is we didn't stop because we didn't know. I've had post getting this thing to work, I've had people describe it to me. So scientists describe it to me as you walked a precipice in the dark and somehow didn't fall off.
Wow.
A lot of it looks like luck, right? We've managed to get stuff to work that really, to common knowledge, shouldn't have worked. And that's, I think, largely because no one was naive enough to keep trying this stuff.
So what was supposed to fail? Why was it so hard, supposedly, to get this to work?
So there's a couple of reasons why you don't melt metal inside the mold. The number one thing would be, and why no one does it, is that if you have a metal mold, it's going to warp under the heat that you're going to put it into. And if you have a ceramic mold, that's fine. You can get them up to the temperature, but they don't like to be cooled down fast. So they want to take like a full day to cool down. Problem with metal is if you cool it down slowly, you get really large grain structure. You can get metal to be almost like glass. You can drop it and it will shatter if your grain structure is big enough. So ceramic, happy to go hot, doesn't want to cool down fast. It shatters under the thermal stress, thermal shock. So yeah, we walked a very fine line, figured out a material. It's a ceramic combination with a binder that allows us to do what we're doing. Prior to that, there's no way you would do this approach because it just doesn't work. And then the second thing is that technically our castings should be horrible. What normally happens in casting is you're casting in the crucible, you're scraping off all the bad stuff, you're injecting it with gases and things to try and get a really good alloy mix, and then you're pouring it in. And I can't talk too much into that, but there's a key thing that we're doing that's kind of unlocked our ability to actually get, and now we're actually beating sandcast or permanent cast in terms of strength. So we're actually getting these really, really good quality castings where common knowledge would say you won't actually achieve that. But yeah. Okay.
And you can't talk about it because that's, I was going to say, so that's your IP basically that you've done. That's why you can't talk about it.
Yeah.
And so after kind of trying this with like hundreds of microwaves, I imagine, and I'd love to see a picture of the microwave wave if you have one, would be great to share. So you started kind of building your own machines, but you had to raise money for it because you were kind of running out of capital.
Yeah. Okay. So this is where the bathtub comes in. COVID hit, and I taught my kids to shower and clean the bathtub as my. So I've got a photo somewhere of a microwave and a 3D printer sitting in the bathtub on sheets of plywood.
Why were they in the bathtub?
Because I didn't have anywhere else. Small house, and at that stage 3 kids. So there was no space anywhere else but in the bathroom.
Jesus, the backyard was completely destroyed.
Backyard, no, we'll go out in the backyard in good weather. But yeah, mixture of the two. In fact, I've got a video of melting metal in the microwave in the backyard. At one point, my son, he's in nappies, walks past. And the temperature readout on the thing is sitting at 1,000 Celsius or something.
Oh my God.
Oh my God.
Early days, dangerous early days. All right, yeah. So
Can you send us that?
I can send you a picture. I can send you that video. Yeah.
We'll add it to that. We'll show it.
Don't do this at home. Lots of stuff.
That's a big disclaimer across the whole episode, I think.
Yeah, 100%. Yeah. And actually, sorry, to be fair, metal in the microwave is dangerous. So it isn't something you want to play with.
Unless...
So we kind of got this working-ish, and again, the reality was that we didn't have metallurgists looking into the quality of the casting, so that they may have looked all right. And I feel sorry for VCs because you've got very little to go on unless you're an expert in the area. So it probably looked all right to a VC, and we weren't aware either. So we raised money out of the US. At that stage, so that was fantastic. Was then able to bring on more people. Couldn't find a microwave expert. Hired this guy Robbie Lopez, who's now head of furnace technology, and he basically taught himself microwaves, which was massive. Just really smart people who are prepared to be flexible. Now we've talked about microwave a lot. We actually don't use it on our first customer machines. Microwave is an interesting thing in that we're printing in powders, and the reason for using microwave was powders are an insulator, so it's very hard to heat anything in a powder. You can take 10, 12 hours to heat a bit of powder all the way through. Microwave, on the other hand, pierces straight through, and that was one of the fundamental reasons for chasing microwave. It is something that we're still working on, still spending money, R&D money on it, but yeah, I think we've become synonymous with the company that's using microwaves for casting. We don't use it all the time. Use it where it's needed.
What do you use if you're not using microwave?
Just conventional. So on small enough parts, you can just use conventional resistive heating. You sacrifice time. Microwave gives us this incredible speed advantage. What became apparent was we were turning around castings in sub 8 hours from start to finish. 3D print molds and then through to these castings in a day. When we started talking to customers, and that's probably another entrepreneurial thing, talk to your customers early. They were saying, well, you're competing with a 6 months turnaround. If it's 8 hours or 24 hours or a week, you're still
so good.
So I think a lot of it, and maybe in vanity, because I realized with this microwave I could push things so fast. It is still the bigger you go in your molds, the more microwave actually pays off to do it. But yeah, that's another subject. So we raised money, hired more people, started figuring this stuff out. Got the first fully microwave version working. Started to learn more. So we Google a lot. Started to learn more about casting and what we were doing wrong and where we'd been lucky. But yeah, got this to the point where we could start making parts for customers, first early customers, and that for us was automotive. So a lot of interest in automotive because they've got that problem. I can show you an automotive one, right? They crash test, right? They want to know if it's going to work. So for them, the pain is they've got no choice but to spend $100,000 or $250,000 on tooling to figure out if the stuff's going to work. Yep. So there's this huge interest and a very obvious use case. Huge interest in, hey, can you get me something that tells me the answers without spending several $100,000? So that was.
You talk to your kind of customers in automotive along the way, right? So I imagine ever since you started identifying that problem to now actually selling it into customers.
Yeah, so we weren't selling it yet because it doesn't at that stage wouldn't run without an engineer nursing it. right? It wasn't ready to be released to the wild, but we were doing it in-house and starting to figure out, like, actually, who's our market? What can it be used for? And so automotive was very much prototype. Yeah, can you make one? That's all we need. And yeah, one, but cheaper and fast, right? Because these guys are literally waiting 6 to 12 months to get their part to figure out if it works. And we were talking to companies who were designing a part, let's say in an engine bay, ordering the tooling for it, whilst they were still developing the vehicle. And then 3 months down the line, they have a major change, major revision, and that part no longer works, no longer fits. But they've already ordered the tooling. So the tooling arrives and they were literally throwing it in the bin, hundreds of thousands of dollars, because it's a redundant part. But they couldn't wait till the end of the design process, because then they've got 6 to 12 months shadow that they're waiting before they can even test what they're doing. So it was interesting for us to see the kind of money people were throwing away because of this problem.
And what was the reaction of the customers when you kind of pitch, or even now, like when you tell them, we can do this much cheaper, much faster? Is it a no-brainer for them, or what are these conversations like?
Yes, once they believe you. Right. The reality is that we've been in this for 8,000 years, so we know how this stuff works. And when you say to them, I can, especially at those days, I can do it in 8 hours, you could see their eyes glaze over and they go, we've heard this whole 3D printing spiel before. And there was, unfortunately, I think in 3D printing, which we're adjacent to, but similar customers, there was a lot of smoke and no fire. There was a lot of promises made. And so when you're talking to the industry that are actually using this technology, you would see their eyes glaze over and they go like, whatever. So that was, and that's still something we're working on today, is building trust. And, we've got a webinar coming up actually this week. We're sitting down with a metallurgist and just showing people, here's what it can do, here's what it can't do, but here's the actual, independent data on what it's actually doing, and just building that trust in the market is a key thing for us.
And what was the experience towards the venture capitalists? They probably had a similar reaction to.
Initially it was good, right? When we first raised in the US, because 3D printing was still on the climb, and I think probably we were riding a wave there. What's happening now more is that venture capitalists are seeing the same thing. And they're saying, well, is this stuff for real? And so that's really a large portion of what we're doing now as a company, is just proving it's real and proving the market.
So tell me a bit more about, how do you, when you go in and talk to a customer, and why do they think you're 3D printing? Because you're not, right?
Well, we're printing the molds. So we're 3D printing the molds. What we're doing, it's now got a name, right? But it's indirect 3D printing. So the actual part that you're receiving is not 3D printed, but we got there by 3D printing. And so we've got the same physical properties as a generic casting, but our mold was printed. So you kind of get lumped in with 3D printing the minute you say that. The minute you say it's 3D printing. And so, a large portion of what we're doing is trying to educate people into what we're doing. So what happened was
So traditionally 3D printing was trying to actually 3D print the actual part.
Actual part, yeah. Yeah.
You're saying no, we're actually, it's a die cast part.
It's an abstraction from it, yeah. So we're printing a mold and then we're casting a part.
Makes sense.
Yeah. So we've now got this technology working in the lab. We're starting to make parts for people. We decided the best thing to do here, and we at this stage we've mostly been talking to automotive. We thought we would go to a trade show. So this Fall Next in Germany, in Frankfurt. So we went to this trade show with nothing to sell. And they were, I don't know if you know about trade shows, they're expensive. They're massively expensive. But the thought was, this is our best marketing opportunity. We're going to this huge trade show. It's the industry leading. It's for advanced manufacturing, additive manufacturing. And let's just see if we can get a whole bunch of data from customers. And we got asked quite a lot, why are you here if you've got nothing to sell? But what we found out from that trade show was that there were a whole bunch of other markets beyond automotive. And what we discovered was the majority of the market is not looking for prototypes. Majority of the market is looking for production. And that can be short run production. That can be bridge tooling. That could be, we need 100 parts of this thing. We need 1,000 parts of it. We need 3 parts of it, but it's not a prototype. We need it to be identical to the production one. Let's say you're talking to a company who, and this is, you will be amazed at how often this happens. Hey, we've lost the tool. We've lost the mold to make a part. It's gone missing in the warehouse. We can't find it, but we need 4 more to finish a customer. And this is big. This is not mum and pop shops, right? This is big companies going, I've got to get 4 more of these things. What am I going to do?
Right.
So we started
and their biggest problem is time
and costs, right?
I mean, for a big company, cost probably doesn't matter so much as time, right?
Yeah, but if you are, let's say you're a company that needs to make 4 more. Let's say it's a vehicle that's end of life. You've got to you only need to make a couple of hundred a year.
Right.
Your cost and your tooling, your amortization cost is huge. You've got 200,000 and you've got 4 parts to make.
I see.
So automotive is actually quite sensitive to price. Prototyping, but in production. But what we realized was I've been working really hard on a prototyping tool, but because I'm not directly printing, because I'm actually casting, all of a sudden this is applicable to production. This is where we see ourselves very different from 3D printing. So 3D printing has got this massive chasm to cross at the moment, and that is how do we go from prototype to production? And the only way that they can do that is to get people to accept 3D printing as an output. You are talking to the most conservative industry in the world, right? Is manufacturing, just about. And so you're saying to them, hey, can you please accept a different result? And often they can't, especially if you're talking defense. They actually can't. You have to requalify so aircraft or it's a vehicle, you have to requalify it. So, and that is a huge process. And we're seeing in the US Defense Force that up to 3-year wait times on castings is preferable to requalifying a vehicle. So anyway, okay. So we realize that we're now sitting on what potentially could be a gold mine, because we've got parts that are very close to the production, not identical, but very close to the production part. One of our customers, and again, I can't talk about them, but they're saying 95% of the way there, which is fantastic compared to where they were with other castings, which was 60%. Okay, so we've got now an industry beyond automotive, because industrial hardware, which is, it's a broad heading, but let's say it's brackets and machinery, it's door handles. When you open your door handle in your house, there's between 8 and 10 castings inside that door handle, and it's very mundane, and 3D printing. And again, sorry, I sound like I'm bashing 3D printing. It's incredible technology. It's amazing.
And it sounds like you guys use it, right?
We use it, yeah, correct. But direct 3D printing. So 3D printing of metal components is still incredible. And if you look at the rocket engines and things that are being made, that's incredible use of it. I'm not really after that though, because that's a tiny piece of the market. There is so much mundane tapware, door handles, brackets on cars. There is just lighting in your roof. It is just everywhere. And that's kind of the market I'm after. That's a market that when you have a very high cost part, like a CNC machined or a 3D printed part, it never makes sense to make it with that.
Right.
If you've got casting and we can see line of sight to being able to make our technology at a price that is cost effective, cost competitive with traditional casting, then that starts to become a really interesting player. And then that probably leads on to this next big thing that we discovered. So obviously we've now discovered that there's a defense market, there's an industrial hardware market, there's automotive, and there's others, but that's kind of the big ones. We're then starting to discover that there is a massive skills shortage in the US. And this is going to why this is a US focused company. There is a skills shortage. So since the 1980s, and obviously, doing a lot of research into this stuff, since the 1980s, America has offshored between 70 and 80% of their casting. Let's split the difference and say there's 25% of the industry left in the US. So it's nigh on non-existent. It's still, it's decreasing. So if you look at the graph of how fast it's decreasing, it's got like 6 to 8 years before there's nothing left.
Wow.
Right. Yeah. So this is a problem, massive problem in the West. Just generally in the West, we've done this.
And so it's all gone to China?
Lots of it to China and India. But China has been opening, if you look at the statistics, they've got about 30,000 foundries. America's got 1,705.
Oh, wow.
If you look at China, they've been opening 600 foundries a year. If you just look at the rate. Yeah, so there is this massive...
600 foundries a year.
This massive difference, right? So you've got 30,000 plus foundries in China. So
Wait, did you say factories or foundries?
Foundries.
Foundries specifically.
Foundries specifically, yeah.
Wow.
So then you've got this current political climate where America goes, whoops, we've woken up to this. Europe, to some degree, but not to the same degree, is waking up to it. But America specifically has gone, this is an actual problem. We have to fix it. So there's an executive order from the White House, is 417. And basically it's saying, hey, we have to revitalize American manufacturing, right? So America is actively looking at trying to fix this problem. So this executive order comes out, and they identify 4 industries. So they go, here's the industries that we need to fix. Kinetics, which is missiles and bombs, and right, they need to be able to. America needs to be able to produce that itself. It can't currently. Then it goes microchips, and everyone knows the CHIPS Act. There's a whole bunch of money getting thrown at that, right? Then it goes batteries, right? And there's a whole bunch of work being done on batteries. And sitting in there at number 4 is castings.
Oh wow!
And there is, that I know of, 3 startups in all of the world that's working on this.
And this executive order, to be clear, this executive order is pre-Trump, right? This is
correct.
This is Biden executive order.
Yeah, this is Biden. So what's really interesting is and I'm learning this because as we become more and more US focused, there's actually bipartisan support for this stuff. Biden brings out tariffs, right? They increase under Trump. It's both sides of the spectrum are going, hey, we are absolutely stuffed if we can't manufacture. And so there is this. I, as a New Zealander, have been across the US roundtables with generals. It is really interesting to see, like, hey, we're doing something. We have to do something. And so getting called into these things. So we, in the process of getting that first raise out of the US, we flipped the company, right? Because already we were starting to see, hey, this is a US opportunity. So it flipped up. So it became a Delaware C Corp, like everyone else, but stayed in New Zealand. So all the R&D and stuff was happening in New Zealand. Okay, so now where am I? We've got this technology. We're suddenly realizing that we're sitting on what I feel like is a gold mine. There is no one playing in this space, and there's a government that's super hungry for it. So, we're continuing to work on the technology, continuing to increase the quality. We're starting to get better and better castings, starting to get really, really intricate detail, which is surprising even myself, and I tend to be on the positive side of things. My team are getting frustrated that we don't have an expert, that we're Googling all the time to figure this stuff out. So we hire ourselves a top metallurgist, and it was a bit of a coup. We managed to get a fantastic one. So Dr. Heinmuller.
You hire yourself a top
metallurgist. So an expert at metal casting, right? But specifically we found ourselves a metallurgist who is a legend in die casting, so understands that world, Strixo casting, but also understands additives. And while we're not doing additives, it means that you found yourself a metallurgist who's open to a weird sector of metallurgy.
Right.
Yeah. So he comes in and he's just revolutionized what we're doing, because we all of a sudden have data on what we're doing. And we've built this technology that's got all these levers, but we don't know which ones to pull, right? You get an expert in, and all of a sudden you're going, pull this lever, and oh wow, we're now getting better quality. So when you look back at what we were doing a couple of years ago, the quality, the actual strength of the part is rubbish, right? And then we plotted this on a graph the other day. You can just see boom, 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 and then Dr. Hein arrives, boom, 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 because we started going, okay, this is the lever to pull to get this result. And that, to me, and maybe for any to encourage any founders, entrepreneurs, is you can, I think we invented the technology out of naivety, and that actually was in our favor, right? We went and did what everyone said was not possible. We've now got this technology, and I'll talk into that in a second, but I've got technology which takes a couple of weeks to train someone on. But at some point it starts to kick you in the butt, because you don't actually have enough knowledge to push this thing properly. It is something I'm trying to be aware of now, is figuring out when is the time that you bring the experts in. You don't want to be stifled, but you also have to realize at some point that you just do not know enough, and you need to get to it. So that for us has been a step change.
So your advice is, like, in the very early stages, be naive, reinvent or try to reinvent an industry that you know nothing about, or that you have expertise about, and then at some point you need to get them involved.
Yeah, correct. I think I had, because of my background in designing for manufacturing, I had enough knowledge to be dangerous, but not enough knowledge to where we are now, where we're actually saying we're actually getting some of the better quality casting in the world. Sorry, that's us. That's maybe a bit of a bold claim. We're beating sand casting, we're beating permanent mold in terms of UTS, in terms of elongation and hardness and things. So I'm starting to get really good quality casting up. But maybe I'll back up a second here, in that I have been pushing the company to this point from a UX perspective. It's user experience. How do we make this easy on the user? At times making compromises so that it's easier for the user. But this now starts to pay off, because we're now saying, well, we've got this massive skills shortage in the US, and the problem is not money. The US is not poor, right? So the US can afford to go and buy casting machines. Absolutely. The problem is that you've only got 25% of your people left. And of those, if you look at the age range, there's a alarmingly high portion that they're in their late 50s, early 60s. And this is the same. You're seeing this across all industries in the US, manufacturing, where we're about to lose all the expertise. These people, what would normally happen is you'd have an apprentice, right? And you would pass this information on. A lot of this stuff is black magic in casting. It is really complicated. It is really complex. And your variables keep changing. Your weather changes, therefore your casting changes. So there's all of this knowledge about to be lost. And at the same time as that, you've got generations who don't want to work in a dirty, dark, dangerous environment anymore. So you're trying to attract people into it, but you're saying you have to wear the suit because you could get burnt so bad you die. Yes, don't go near that stuff because it could explode. If water gets into it. And it's really, I don't know if you've ever been in a foundry, but there's smoke in the air and they're dirty, right? And so the problem here is not that America can't afford to build the machines. It just doesn't have the people to run them. And it doesn't have the expertise anymore, which is incredible, but it's the truth. And I think at the moment in America, the concern is that the war machine is being built offshore. And so if something were to happen, how does America get back? Well, it can't. It can only produce at 25% of what it used to be able to produce in the 80s. And what it produced in the 80s is far behind what the rest of what China or India or other countries are producing.
So to that point, you've got a partnership now with the New Jersey Innovation Institute and the U.S. Army.
Yeah.
Right? So what is it? Can you tell us about that? It sounds like you went from automotive to now working with the defense and the military.
Yeah. Yeah. And I guess this is probably going back to that point that we were focused on one industry. When we actually got out and going to trade shows is great because you get all sorts of industries coming. And what became apparent was defense is hurting a lot. So what's happening for defense is the foundries that survived in America, defense is using those. Right. What's happening now is Trump's putting tariffs on castings. Biden put tariffs as well. So then you're seeing companies saying, hey, actually, I need to build this onshore. So there's all this onshoring happening, which then means that the few foundries that are left are starting to get bigger orders. Then Defense Force is this really interesting beast in that it doesn't ever produce a lot of anything. So the Defense Force might come and say, I need 14 of this piece. And the foundry's going, I've got a 200,000 order. So what am I going to do? And so what's happening is that from what we can see is that defense orders get pushed back and back. And so we are literally talking to people who are waiting up to 3 years for a part. And that's untenable, right? If you have a vehicle that's down for 3 years because you're waiting for that part, that's a huge problem. The other thing we're seeing, Defense Force, so they are hurting more than most, and they're looking for solutions. So it is maybe not our biggest market, but at the moment it's the most urgent market. And I think at the moment we're seeing the tide has turned where America's actually, especially within defense, is looking for solutions.
Would you say that's currently your biggest market right now?
No. I think industrial hardware is going to be a bigger market than defense will be.
So what's next for the company? So you're in America, you're exploring these different industries. What are you planning to do in the next year, 3 years, 5 years?
Yeah, gotcha. Okay, so going back to that question you had before, we talked about before, was building trust. So what we're finding, so we've sold a couple of machines. We've just crossed the $1 million revenue mark, which is fantastic. The reality is, that's huge to go from R&D to actually making money. What we are discovering though is every company that we talk to is, hey, before I look at buying a machine, can we just make stuff for us? And what we figured out was a lot of that is building trust. They need to build a model that they can sell internally to say, hey, this is, we're getting good enough quality, it's at this sort of price, and we have this much work for it. So yes, it makes sense to buy a machine, but we need to get customers to that point. What we've done is a bit of a pivot away from selling machines and saying for the next 18 months or so, we're solely going to focus on Foundry as a service. So maybe think of it as the AWS of casting. It's the idea is you can tap into the service, you can get your parts extremely fast. Again, we're knocking months off what a normal foundry would take to get there. And so what you're buying is speed. So you can get your castings from us. We'll turn them around the fastest. Essentially what we're saying is the fastest foundry in America is what we're doing.
And David, I mean, that feels like maybe an even better product than selling a machine, right? Because a machine has a longer sales cycle. It's more expensive. You need more buy-in. Whereas if you're like, hey, just buy a part from us, it's much cheaper. It's much faster. It's you already have budget for that, and it's like a no-brainer, right?
Yeah. Yeah. So big enterprise sales. Yeah. It is, I think, what happens. So absolutely. We're going to see how far we can take this. I think what happens is as you're doing higher and higher quantities, and again, what we're very aware of is 3D printing got stuck in a valley, and that was trying to jump into production, struggling to jump into production. We don't want to get stuck in that same valley. Right. So we're always got one eye on what are we doing in the future in this production. And so going, okay, there is a point at which when you're making enough of a part, you normally get economies of scale. So if you bought the tool, it might cost you $200,000 to buy the tool, but your part cost is low. So if you use us, per part price is expensive, but we start down here at zero setup cost. Whereas if you're buying these other ones, your setup cost is huge. And it's
amortizes, right?
Correct. There's a crossover. And so looking at that and going, running a Foundry as a service, obviously I've got costs involved in that. And so that we start to compete on price at some point. Whereas if you owned a machine, all of those overheads and stuff, I no longer have to charge you for that. So you're just paying material cost.
Oh, so you're saying you're competing against yourself. You're not competing against other foundries. You're competing against two business models, Foundry as a service versus selling machine.
Yeah, well, Foundry as a service, it starts to compete with generic foundries on per part price when you get higher quantities.
But at that point, you sort of allow them to buy the machine. Or does it still just...
No, that's correct. So the idea would be that your Foundry as a service is a flywheel. It gets people to trust the technology, it gets people to like the output, and then it's saying, hey, if you need to compete on a per part price, it really makes sense to own a machine.
But
so you're trying to flip over after you said 18 months. So basically starting as Foundry as a service, and then at some point you're like, okay, now you're like, economically, it makes sense for you to own the machine.
Correct.
And you help them, I guess, to train up personnel to actually operate those.
Yeah. And it's, yeah, exactly. It builds that trust. They can come in and see a functional foundry using this technology.
David, don't you still have even with the machine in house, you're still producing them kind of one by one. You don't have the economies of scale right? So you're still at some point is going to compete with a traditional foundry, but just going to be a later point.
Correct. So owning a machine, it pushes that out. So now it might not be 100 parts, it might be several thousand parts before you cross over that. And then again, it depends on what the company is doing. But there's a opportunity cost here as well in that you design a part, you cast it. If you get it wrong, you throw the tool away. Mm-hmm. We've got, and let's say the crossover point's 1,000 for argument's sake. You've got 1,000 tries with us to get it right, and that's a really important thing there, right? Because you might be competing against the price of a single tool, but in reality, you might have done 2 or 3 before you got it right. And so there's that crossover. But essentially what the Foundry as a service allows us to do is at some point get people interested in buying a machine. Yep. We will continue to do Foundry as a service. So it's not going to go away, but we're going to bring back in the ability to buy machines. Yeah. And so we're taking orders now, but it's just for machines.
I mean, what I find interesting about this is also that, I mean, the way you probably modeled this out, there's probably a certain market for, foundries and for metal die cast parts. If you're offering the ability to get something maybe 2 times cheaper and like 4 times faster, all of a sudden the market actually expands, right? Because everyone who before didn't realize that they can do this or had to use other methods or didn't even try something because this is out of budget both time and money wise, all of a sudden can now create stuff and do stuff, right? So you actually expand the market.
Bang on. So this is a really difficult one to speak to VCs about because we're essentially creating a category. And so when they say, well, how big is the market? I'm going, well, we've got some indicators, but it should grow beyond what we can see. Uh-huh. And the best things are to look at, well, how many people or how much CNC machining is being done on parts that should have been a casting, or how much 3D printing has been done on a part that should have been a casting, or how much has been spent on tooling for parts that should have been prototyped first. And so looking at all of those and just trying to figure that out. But you're 100% right. The other thing that's really, and this gets me quite excited, so when you're designing, okay, we'll go back to that part, right? When you're designing a part, right? This has got super thin walls through this section. As a designer, you avoid that kind of thing. So you design middle of the road because that there's no way to prototype. That the tooling cost is so high that if you get it wrong, you're going to get it in the neck. So you design with safety factors, you design middle of the road and you use more material, right? And from an ideological perspective for me, looking at this going, okay, I'm going to give a person the chance to, within a day or 2, have the part, try it out and go, you know what, I can afford to test. I can afford to try things out. And the net gain in the end should be that we get better metal castings. We use less material, and overall the world's better off for it. So I feel like we're going to give designers freedom in metal that they've never had before, which then means you start to use metal more than you would have. And this stuff is infinitely recyclable, right? It just keeps going and going. And it becomes a really interesting play longer term.
One thing I think about, right, is like back in the early like thousands, 2010s, like because of the ability to a lot of like smartphones, like there were supply chains that got set up around these like the different subcomponents. And because you had this like consumer hardware, like Revolution, Kickstarter got started on top of that, people just making consumer hardware, right? Whether it was toys, whether it was like productivity, whether it was like just help, like, I don't know, smartwatches, things like that, right? Pebble was a thing. And kind of makes me feel the same kind of energy, right? Like, could you have people just prototyping in a garage and all of a sudden make real, like, can somebody just make a car, for example, right, in your garage using Foundry as a service? Do you think that'll happen? Do you think that you will enable that kind of stuff?
Yeah, absolutely. Because all of a sudden it becomes possible to make a part for a couple of $100 that would have been $100,000 of tooling. So definitely people start doing stuff. So absolutely. I think it gives you another explosion in creativity and design.
What kind of things? What's your guess? So like, what are things people will start? Well, what's the lowest hanging fruit that people will start? Like individual, like, so I understand companies B2B, that's what you're focusing on. But like, just like a regular like Kiwi and messing out, in the garage.
And this might be a little bit boring, right? But we get, I don't know how many inquiries for people who are saying, hey, I've got a Model T, or I've got some old vehicle and it's missing a part, or this part's broken, need it cast, right? And I need one off. That is like the quintessential use for casting that we're getting from people, from individuals. Hey, can you just make me this part for my car?
But it could also create like a whole new generation of hardware startups, right? Because the cost of prototyping becomes so much cheaper and you can test out so many more things.
Well, you just look at it and go, well, how many barriers, how many things could have been done, but the barrier was cost. So it never happened. Yeah.
Have you heard of a company called Plethora?
No.
They're out of business. They got started about 12 years ago. I know the guys who founded it, but they were basically doing CNC machining as a service.
Okay. Kind of like Hadrian.
Yeah, maybe. Yeah. They ran into a lot of problems, and I think it was probably too early, but I think they were trying to go after a similar kind of vision. Yeah. It's I think timing is really important, right? Like, it feels like now there's a lot of tailwinds, right?
There's tailwinds, both political and also just, there is this massive shortfall. And so there is this, the way we're looking at it and going, if there's 25% of the industry left, you've got, hear my maths right, so 75% of the industry to rebuild, and you can't use traditional technology for it because you don't have people who know how to run it. So if I'm doing a technology now that I can train you in 2 weeks to run, then all of a sudden, and it's not a dirty dark room, it's clean room kind of stuff here. This is more knowledge worker than it is Foundry worker. Then all of a sudden you've got people who can run this thing.
What does that look like, right? Like, I mean, does that look like? Where does that kind of put us? Like, do you see just an explosion in certain types of products, certain types of manufacturing, certain types of companies getting started, or what do you think that kind of enables? What does the future kind of look like with the limit, everyone kind of being able to access this?
I think, yes, to some degree there's new stuff happening, but I think a lot of this is just supporting in America. America then starts to innovate again. And so this is not meant to be harsh on America, but what I think happened was people offshored manufacturing, and the general feeling was, this is the dumb stuff. We're going to give this to other people to make, and we're going to keep the knowledge in the US. The reality is, the minute you stop making yourself, you stop innovating. And so the people who are now making start going, well, what if I change this? What if I change that? What if I do that? And then all of a sudden they're starting to innovate. And I think what's happened in America is we've been very good at innovating same day delivery of your junk, and we've stopped innovating on manufacturing. We stopped innovating on making stuff. So what I think this unlocks to me, and this again is ideological, but what this unlocks is America starts to innovate again. America starts to be back at the top of the food chain in terms of technology. And for me, it keeps a world order that I think benefits New Zealand. And this is something that we're expecting to get criticized on. We've just sold a machine through to the Defense Force. It's NJII, so it's not actually, it's an in-between with the Defense Force. But I think a lot of New Zealanders are going to be upset by why you're going that direction. I've been on quite a journey in the last 2 years, realizing that we are sitting under the shadow of the US, the protective shadow of the US. And it's all very well to say don't get involved in US policy, etc., which we try and keep out of. But the reality is a strong America is what keeps New Zealand safe.
Can I?
Yep.
Just on that, just because I'm European, right? And the conversation in Europe at the moment is how can we be more independent of the Americans? Is that going to be a future market for you as well?
Absolutely. So Europe is huge. In Europe, automotive, they actually make more cars in Europe, right? So that was for us as a really big, but the swing towards rebuilding America has been the strong pull. What we're seeing in the EU is there's not a, Trump, whatever you think about him, he has just gone, this is what we're going to do. Boom, right? I think in Europe, we're not seeing that kind of decisiveness. We're seeing everyone going, well, we're not sure what we're going to do. Whereas Trump is going, tariff. I mean, that's a massively unpopular thing to do.
Mm-hmm.
And that's in my benefit massively. It's going to drive work towards, well, how do we get onshore in the US fast?
Mm-hmm.
So Europe, absolutely. We're seeing our big markets as America, Europe, Japan. Right, three big markets for us.
So David, are you ever going to sell to China?
Probably not. As an industrial designer, I worked in China a lot. China is, and I don't want to sound negative on China. China is incredible. We could get stuff manufactured. It's not just price. I think a lot of people mistake China for being cheap. If you want quality, you still pay for it. The thing that China has got is set up. Everything is there, even down to the way their highways lead to the ports and things like it. It is designed to manufacture and ship. So that is incredible, and you can get really high quality out of China. I think that's also a misunderstanding people have got. You pay for what you get.
You spent some time living there, right?
Sorry?
You spent some time living there?
No, I used to go across for work a bit, but never living there. I think one thing that concerns me is we would get products manufactured in China for our customers when I was doing my design time. We would also get copied extremely quickly. I think the worst one we had was about 6 months from the time that we launched the product to the time that there was an alternative available at a lower cost than we could achieve. And so that does concern me. I mean, we're patenting in China, but it is, at least let's say in the current political climate, it probably doesn't make sense to be in China, but it's a massive market.
So what does the company look like in, let's say, 5 years?
Yeah. In 5 years' time, so at the moment we're doing aluminum. We're really focused on aluminum. In 5 years' time, we're doing steels. Standard steels, we're doing high temperature alloys. I think especially alloys that the US Defense Force is interested in. I think we're doing much bigger parts. That is, that's about as big as we can go currently. So
that's like as big as what, like your head drilling? That was the size?
Yeah, let's say it's a 1 foot cube for the Americans. Okay. I think we're selling machines into companies and we're supporting them with that. I think we are, in 5 years' time, starting to redefine casting. So I think what we're doing now and proving that our technology is actually, the quality is good. What I'm hoping, and I believe we're going to see, is people going, this approach gives me a better quality casting. I can get fine detail, like this, we're talking less than a millimeter through sections. So I'm getting better quality. I'm getting finer detail. I don't need a workforce. You need a workforce, but hardly anything compared to traditional foundry. I don't need to have these trained people. I don't have to have 5-year apprenticeships to get there. I think we start to see people saying, well, why am I using the old way of casting? And so that's 5 years is maybe ambitious to redefine the industry, but I think we're starting to see people going, this just makes more sense than traditional casting. What I'd like to believe is in 10 years' time, people will be looking at it going, why did we ever do what the Egyptians did? Like, that doesn't make sense. And I think the key thing here is we have control of the process. And so we can digitize the process. So all of a sudden it's no longer your old casting expert who's lived through enough winters to know what to change when it gets cold or the humidity comes up. Or this is just digitized. It is agnostic of who's pushing the button. And so at some point, I think it's the same as what we're seeing with this AI, the AI world, right? We're going, well, this just makes more sense. And so I think there's that redefinition of casting.
Tell me a bit more about the journey you personally went on to think about the world order that we live in. And yeah.
So we were contacted by a certain agency. I'll talk about it. Certain group in the US government about what we were doing.
I don't know, we're out of the blue. They just call you up.
Yeah. So
They're like a phone call or an email or like what?
They sent me an email. And I said, look, I'm not interested.
You say you're not interested.
Well, I didn't want to be, I said, look, I don't want to kill anyone. That's fundamentally where I stand. I don't want to kill people, so I don't want to be involved. And over the course of about a month, we were talking. And there was this, hey, David, I think they got me thinking, right? And I was going, well, why am I not interested in this? It's a massive market. And talking with people in direct 3D printing, and they were saying, hey, 50 to 75% of what we do is in the defense. It's always government anywhere. And I got told by one CEO of a really big 3D printing company that I was cutting my knees off if I didn't go for it. Cutting my legs off at the knees. So I was looking into this, and I think one of the key things for me was shipping. New Zealand, as you know, is an island in the middle of nowhere, right? We are 100% reliant on shipping. And what I was seeing was there was, and it's still going now, right? But piracy was becoming an issue. And I realized that when you look into it, our shipping routes are patrolled by America, and America is blowing pirates out of the water so that our shipping happens. And I'm sitting there going, well, I want them to do that, right? And then going, well, that's a bit hypocritical. And then at the same time, the whole ISIS thing started. And my reaction was, go America, go get the bad guys, right? And then going, well, that's also very hypocritical, because how can I sit here saying America is wrong and foreign policy is wrong? And look, I don't agree with a lot of foreign policy, but it is very hypocritical to say, hey, do all that stuff, but also protect me, keep me safe. Sorry, don't do that stuff, but I also want, you start to get the image of flea on the back of the horse, right? That's, we're living off the horse and saying, don't do this, don't do that. And, but also protect me. I still have massive reservations in terms of what we want to get involved in. But I'm definitely at the point of saying, actually, I've got to the point where I'm saying, I think supporting the US defense and I don't want to make mortar shells, right? But definitely a bracket that is inside a Humvee that keeps the engine in place, or, so there is, for me, there's still a line that I haven't been able to cross. And that is, I don't want to kill people, right?
It's interesting that, you've had this kind of like, and it makes a lot of sense, right? I think like, I kind of don't fully understand like why people, Kiwis, or non-Kiwis, Americans, there's a lot of like questionable things in the U.S. Army or whatever the U.S. government does, but at the end of the day, like there is a certain kind of way of life that we all have because of it, right? And so why do, because you mentioned a lot of Kiwis would sort of have, there'd be a backlash against you saying that. Well, why do you think that is? Well, how does that kind of make sense?
Yeah, I think there's just in a general, at least at this point in history, a psyche in New Zealand that is just, hey, do we have to do war? Do we, like we are, and you'll know in New Zealand, it's a very peaceful nation. It is still built on old school values, I think, to some degree, where all of that kind of stuff, you'd rather just avoid it, right?
All right.
And I think, probably the time for avoiding it is ending. I think when you start looking at what potentially could happen globally in the next 4 or 5 years and going, well, we are going to be careful what I say so I don't get myself into trouble. I think if things go south quickly, as a country, we're going to have a very interesting conversation with ourselves and saying, well, where do we stand here? And can we be neutral, or do we actually, do we have to get in behind who we think aligns better with our?
I think these things can change overnight, right? I mean, in Europe, in Germany, like the median voter has been pacifist just until 2022, and when the Ukraine war started, like people shifted overnight into like we have to spend billions and billions on our army.
Correct.
So there's got to be this event, and then suddenly things move.
I think what's happened for me is I've been exposed to the reality. I think in New Zealand you can hide from reality, right? You can. That's very far away, right? I ended up getting called into these meetings in DC and other places where you find out how bad things actually are and how close we are to conflict.
Can you share whatever you can share? I mean, just so like kind of, because I think it's important to kind of bring that information out so people understand, right? Like where things actually at.
Again, I got to be careful what I can actually say. I think what I didn't realize before I started getting called into these meetings and getting involved in this stuff was how close we are to conflict and how seriously other countries are taking this.
With China specifically.
With China specifically. And I think a lot of it, Ukraine has definitely pushed people's thinking in that, right? Where the unthinkable happened, someone in this day and age went to war. Smart people went to war. Like, how could that be? And I think New Zealand is sitting here going, well, smart people won't, smart people stay out of this. But the problem is it's happening regardless of what you think. And so then going, well, do we want to be the country that is so ill prepared that we send people out to slaughter? Or do we want to be, getting prepared for this? And to me, what I'm doing, while wasn't initially for defense or anything like that, I can actually be part of the solution. And from my perspective, right, deterrent. I hope that my stuff never ends up in a war zone. But there is this deterrent. At the moment, America is toothless in terms of manufacturing, and the world knows it. So, hey, they cannot, I don't know if you know about, Freedom Forge. So World War II. America mobilized its industry. It's not defense industry, commercial industry, to go, Ford went and made bombers and all these companies. That doesn't exist anymore. So going, hey, America actually can't right now build a war machine. And so you're seeing, and that's why it probably frustrates some people, but you're seeing huge money being spent on groups like, like Andurils and Saronic and all these other companies that are building up this ability to manufacture. And if nothing else, what it's doing is it's saying, hey, we are able, if we had to, we are able to meet a conflict. And so therefore, kind of what I'm looking at with our stuff is saying, well, if America has this technology, they can build and respond extremely quickly. And that's a deterrent, saying, okay, well, I now know America's got teeth again. Yeah. So that's where I'm seeing ours.
David, I mean, is the main concern China's invasion of Taiwan? Because I don't think China's ever going to invade or do anything to America itself or New Zealand itself. It's just so far. Well, what is the actual kind of threat?
Yeah. Okay. It is multifaceted, and I don't claim to know everything on this. But if you look at Taiwan, the concern there, from my understanding, is Taiwan is the biggest builder of microchips, which is why you're seeing so much money being spent in America on microchips. If Taiwan was invaded, America loses the ability to compete electronically. And what we're seeing is that the war has changed. Now, I don't know how we've got so deep into war, but we're seeing war has changed. It's no longer going to be, I've got the biggest machine. It's going to be, I've got swarms of stuff. I think, what did I see the other day? That a $30 billion or $300 billion aircraft carrier can be taken out by $3 million worth of drone. It's a complete change, right? And so then all of a sudden, microchip becomes one of the most important things. America loses Taiwan. America is on the back foot. It can't compete, and therefore will be beaten in the technology war. So that, to me, that's my understanding of why Taiwan is such a big deal. So whether it is actually open war with America or whether it's just over Taiwan, yeah. But then I think, in Ukraine, the question is this going to spread further? And I think I saw a podcast the other day with ex-head of MI6, just saying that Europe needs to have hard power, right? And it's it's building up, and it's for no other reason than being a deterrent. Going back to, again, I don't want to sound like a warmonger because that's really not me, but I think we can play a role in being that deterrent.
And I think that, I mean, for me, what the most interesting part is how can we be sovereign, right? How can we be independent of, China, Asia, and in the European case, how can we be more and more independent of the US if they don't want to support European sovereignty?
Yeah. And this is actually one of the things that we lead with when we're talking to people about the technology, is we say, hey, this is sovereign capability. What's really interesting, post-COVID, so we call it post-COVID shock, in that we've got all these companies who are saying, I lost the ability to make anything during COVID. So I want some ability to bridge times like that. I think there's a naivety as well in thinking that people won't go for where the lowest dollar is on making stuff, right? So if tariffs mean that China is too expensive, they'll move it to Vietnam or they'll move it to India or whatever. So what I don't think companies are looking at moving their mass manufacturing to America yet. Right? That's more bravery by the government. I think what we're going to see is companies saying, I want sovereign capability to determine, at least for a while, what I can do. So if I have to move my tooling out of China and I've got to put it into Vietnam, I'm going to have several months downtime whilst everything's being set up. What do I do in that time? Or if there's another COVID breakout, what do I do for the 3 to 6 months that I can't manufacture offshore or whatever? So it's that I think is coming back in, and that's exactly where we fit. It's the short to medium run. It's the short term. Yes, it's more expensive, but I've got control of it. And so that's what we're seeing companies saying. We're looking at technology that allows us to have sovereign capability.
Makes sense. Cool. Well, we spent a lot of time together. I appreciate your time. But what sort of, maybe as a last sort of ending remark, I mean, what are your thoughts about building in New Zealand? What advice do you have for kind of Kiwis and Aussies building here and in Australia, building for a global market? What learnings, advice?
Yeah, gotcha. I think I can't speak for Australia. Don't want to offend anyone there. Kiwis are smart. Kiwis are really smart. What we're finding is Kiwis are also very flexible in going, hey, I'll have a go at that. Right. And so that has been fantastic. We have, it's that same thing, blessing or curse. We're so far from everything that you end up making up your own stuff. That can bring about new ideas. That can bring about change, a big change. What we have to realize though is that like what we're doing now is bringing in experts at the right time. So by all means, as New Zealanders, go out and let's push the boundaries and go and figure stuff out that other people wouldn't have, because I think it's impossible. And then at the right time, bring in the experts. The problem there is, for New Zealand anyway, is trying to get people into the country. So definitely, if the government can do more on that side, making it easier for people to get across here. We've had to get people in from overseas, and so we've had to go through the visa process. But the more you can do to attract people to New Zealand, the better. Yeah. I think as well, maybe it's just worth noting, the center of 3D printing is Germany, and then US, MIT, and all of that. There's I think anyone, if you went to a VC and said, hey, I'm going to build a 3D printing company out of New Zealand, they would probably go, don't, that doesn't make any sense. You don't have experts there and stuff. So you have to be countercultural, and it's hard graft, right? You've got to get a team of people who are prepared to just push into the stuff. But look, we're not a success yet, but it's been, what we've achieved has been amazing, for the fact that we have no MIT professor who's done 3D printing for the last 20 years. So.
Yeah. That's incredible.
Yeah, no, really, really exciting what you're building. So thank you so much, David. This has been really great. And we look forward to following your journey.
Hey, thank you. Thank you for your time, Beth.
Thank you for tuning in to TechMates. If you enjoyed this episode, be sure to subscribe, leave a review, and share it with friends. We'll be back soon with more stories of Kiwi and Aussie founders reshaping the future and disrupting down under. Until next time, keep dreaming big and daring to disrupt.